The distance that Scott walks is a function of the time that he spends walking. Scott can walk a half a mile every 8 minutes. Assume he walks at a constant rate. Predict the shape of the graph of the function and explain. Since there is a constant rate, we know that we can write a linear function to represent this situation. And linear functions create straight lines. Then it says write an equation to represent the distance that Scott can walk in y miles in x minutes. So first we need to figure out his rate, which is also known as the slope. And in our equation, it's using the letter m to represent slope. So for rates, we do the distance over the time. He walks a half a mile, which is the distance, in 8 minutes, which is our time. If you were to change that, you could multiply the top by 2, which gives you 1, and the bottom by 2, which gives you 16, to help get rid of those decimals. Or you can change that fraction into a decimal all on its own. Now, he doesn't start with any miles already walked, so his b value, or his y-intercept, is just 0. So our equation is y equals 1 over 16x, or you can write the 1 over 16 as a decimal. Then in part C, it says to use the equation to determine how many miles he can walk in 24 minutes. Minutes is the x value. It says x is in minutes. So we are going to substitute the x with the number 24. That means 1 times 24 is on our top, and 16 is on the bottom. When you divide 24 by 16, you should get 1.5, which is miles, because it says in miles for y. D says use the equation to determine how many miles Scott can walk in 12 minutes. The minutes is still the x value. That means we now have 1 times 12 on the top and 16 on the bottom. If you do 12 divided by 16, you end up with 0.75, which is the same as 3/4 of a mile. Part E says determine how far he can walk in 16 minutes. Our numerator is 1 times 16, and 16 over 16 is 1, so he can walk 1 mile. Now it says to write your inputs and outputs as ordered pair. We input 24, and our output is 1.5. In this point, we input 18, and our output was 0.75. Did I say 18? 12. We input 12, and our output is 0.75. On this one, we input 16, and our output was 1. And then you can see that we are graphing those points. So over to 24, up to 1.5, over to 12, up to 0.75, and over to 16, up to 1. What shape does the graph appear to take, and does it match your prediction? In part A, we predicted that it would form a straight line. Now it says connect the points to make a line. What equation is used for this line? And we already said the equation was 1 over 16x. In number 2, graph the equation of y equals x cubed for positive values of x. Organize your work using the table and then answer the questions that follow. 0 cubed is the same as 0 times 0 times 0, which is just 0. A half cubed is a half times a half times a half, which is the same thing as 1/8. And as a decimal, it is 0.125. 1 cubed is 1 times 1 times 1, which is 1. 1.5 cubed is 1.5 times 1.5 times 1.5. 2 cubed is 2 times 2 times 2, which is 8. And 2.5 cubed is 2.5 times 2.5 times 2.5. Plot the points. 0, 0, 1, 1, 2, 8, and then the ones that are in between. Then it says, what shape do these appear to take? This creates a curve. Is the graph a linear function? No. It is not straight. And the variable has an exponent besides a 1 or a 0. It has that 3 up there. D. Consider the function that assigns to each positive real number s the volume of a cube. So it's saying the volume is equal to the side length cubed. What do you think the function will appear to look like, or what will it look like? And explain. All they've done is they've taken that y value and replaced it with the letter v, and they've taken the s value and replaced it with the letter s. The x value is replaced with s for side length, y is replaced with v for volume, but it's going to be the same inputs and outputs. So this will create a curve. They've just changed out the letters. E. Use the function in part D to determine the volume of a cube with a side length of 3. So we're inputting the value 3 in our equation. 3 cubed is the same as 3 times 3 times 3. So y is 27. And then we could say that the volume would be equal to 27 units cubed. It says, does that point appear to belong on the graph? If we went over to 3 and we went all the way up to 27, would the line go through that point?